Okay, but I still can share my screen.
Yes. No, you should be able to do it. Come on.
No, still can. Still can't. Still not.
Vicente, I will send you an image with the menu where I by Skype, for example.
What's wrong with this, Vincent? Sorry. I can share the screen.
You have the icon next to the camera. Come on, do you see it?
Yeah,
It's
yeah,
like two screens.
yeah. I
Can
click
you
that.
share?
I click that, but it can be so always back to others for my picture and others. Okay. Off air. What's the off air? Okay. Okay. I
Possible?
will. No.
It's just a little menu, a little button that you have play or pause or stop, and just there it is from the different circles that you have change presentator, mouse and keyboard, or stop sharing the screen. Now
No, it's okay.
Now it's okay. And you have just a little arrow that you can open a drop-down menu and you can choose the screen that you want to share if you have different screens, you know. But now I can listen to you.
Okay. In 5 minutes.
Now,
We will.
perfect.
Okay.
Perfect. Okay.
In 5 minutes we will conduct the webinars. Maybe it's okay. This is we can start in 5 minutes. Vincent, Hernan.
Okay.
Okay.
Perfect.
Maybe I will make an opener after I have a little bit of presenting. You will start the presenting, Mr. Hernan.
Okay.
Okay. In 5 minutes, right? Is recording yet, Vincent?
Yes. Later we can cut this time. Well, feel free to start whenever you want.
Okay, we will start now. Okay. It's already recording, Vincent?
Yes.
Okay, we will start now. Selamat siang Bapak, Ibu, dan teman-teman sekalian. Semoga kita semua diberikan kesehatan ya. Selamat datang dalam acara webinar CYPE Indonesia dengan tema hari ini, New Structural Solutions in the 2021 version. Menggunakan solusi dari CYPE untuk struktural, salah satunya adalah CYPE CAD, BIM, dan lainnya. Yang merupakan salah satu rangkaian webinar CYPE Indonesia yang menggunakan pengantar bahasa Indonesia dan bahasa Inggris. Dan bersama kita juga sudah hadir internasional CYPE expert yang akan menjadi presenter di webinar kali ini, yaitu Mr. Hernan Ludovici, Technical Support Engineer at CYPE. Webinar kali ini akan berfokus pada apa itu CYPE, BIM server dan alur kerja Open BIM pada CYPE, solusi struktur terbaru dari CYPE. Webinar ini diselenggarakan oleh Arkilantis berkolaborasi dengan CYPE dan CYPE Indonesia melalui online forum GoToWebinar. Berikut saya bacakan tata tertib untuk peserta selama webinar ini berlangsung. Seluruh mikrofon dan kamera peserta akan dimatikan secara otomatis oleh host. Sesi webinar pada hari ini akan direkam dan rekaman akan dikirimkan kepada peserta. Kami menggunakan sistem first come first serve bagi peserta yang telah mendaftar. Bagi peserta yang akan mengajukan pertanyaan atau komentar, dapat menuliskan pada fasilitas Q&A, kemudian oleh panitia atau moderator akan membacakan pertanyaannya untuk kemudian dapat dijawab oleh presenter dan moderator. Dimohon untuk menggunakan kalimat yang singkat atau to the point dan tidak mengandung sara. Pertanyaan Anda akan dijawab oleh presenter dan moderator disesuaikan dengan waktu yang tersedia. Webinar hari ini terbagi dua. Pertama, akan saya presentasikan mengenai apa itu CYPE dan bagaimana CYPE dan BIM Server Center. Dan pada bagian kedua dilanjutkan oleh International CYPE Expert pada webinar hari ini, yaitu Mr. Hernan Ludovici. Baik, saya mulai presentasinya. Okay, are you see my screen, Hernan? Mr. Hernan?
Yes, perfect. Yes.
Okay, perfect. You can hear me too?
Clearly.
Okay. Mari kita mulai. CYPE version 2021. Solusi struktural. Jika melihat logo ini, Bapak, Ibu, atau teman sekalian mungkin masih belum paham dan mengerti apa dan bagaimana CYPE. CYPE adalah perusahaan pengembang software yang telah 36 tahun lebih berkiprah dan memiliki lebih dari 150 software yang telah diluncurkan. Memiliki 170 profesional dan lebih dari 20 resellers, dan lebih dari 100.000 pengguna di lebih dari 60 negara di seluruh dunia. Mengusung teknologi Open BIM, metodologi kerja berbasis pertukaran informasi dan data melalui format terbuka untuk menghasilkan dan mengelola representasi digital dari karakteristik fisik dan fungsional yang ditempatkan sebelumnya, selama, dan setelah konstruksi. Menggunakan AFC sebagai Open and Public Standard Formats, juga memiliki collaborative workflow. Bersama kita akan membuat kekuatan atau Union Make Force, kemudian juga memiliki durability informasi yang cukup lama dikarenakan menggunakan Open BIM format tersebut, dan juga menggunakan specialist description dan delimited responsibilities. Dalam sebuah Open BIM project terbagi menjadi 4 besar penggunaan aplikasi, yaitu dimulai dari pemodelan arsitektur, kemudian juga aplikasi untuk kalkulasi, simulasi, dan analisis desain, terus kemudian juga dilanjutkan dengan interoperability, dan juga databases atau basis data. Untuk aplikasi, kalkulasi, simulasi, analisis, dan desain, CYPE telah memiliki pengalaman lebih dari 36 tahun. Kemudian pada tahun 2017, meluncurkan platform untuk interoperability berupa BIM Server.Center. Dan tahun 2019 juga memiliki dan meluncurkan Open BIM Systems. Dan di 2020 menelurkan solusi untuk pemodelan arsitektural berupa CYPE arsitektur. Ini adalah diagram sederhana mengenai Open BIM yang dilakukan oleh CYPE. Pada kehidupan sehari-hari, kita akan melihat pada konvensional, kita akan melihat dari mulai arsitektur, struktur, dan fasilitas bangunan akan berjalan linear seperti ini. Dari arsitektur ke struktur, struktur kembali lagi ke arsitektur lagi kembali ke struktur, begitu selesai baru dikirimkan ke fasilitas bangunan. Sangat tidak efisien dan tidak efektif. Tapi dengan Open BIM, maka dari arsitektur kemudian kembali ke struktur, dan dalam waktu yang bersamaan juga secara paralel dikirimkan ke fasilitas bangunan, kemudian dari fasilitas bangunan akan kemudian juga bisa dikembalikan ke struktur untuk kemudian disesuaikan dan kemudian disimulasikan dan didesain. Sehingga proses yang secara paralel ini akan menjadi lebih cepat, efisien, dan efektif. Ini adalah diagram dari Open BIM yang dilakukan oleh CYPE dalam environment ataupun lingkungan pekerjaannya. Dimulai semua dari physical 3D models. Physical 3D model ini didapat baik dari menggunakan CYPE arsitektur maupun juga menggunakan authoring software lainnya. Menggunakan Open BIM format ataupun menggunakan format file terbuka berupa AFC, kemudian dikirimkan ke dalam BIM Server Center sebagai platform interoperability. Di BIM Server.Center ini, kemudian informasi mengenai physical 3D models itu ditarik oleh semua tim yang terlibat dalam proyek tersebut. Dari masing-masing disiplin, kemudian informasi itu dibuat ataupun dikalkulasikan, didesain, kemudian juga disimulasikan berdasarkan disiplinnya mereka masing-masing. Baik itu plumbing, baik itu electrical, baik itu dan simulasi yang lainnya, dan juga struktur. Jika sudah selesai, mereka akan kirimkan kembali ke BIM Server.Center. Jika masih belum ada kesesuaian, masih juga bertemu dengan clash ataupun benturan, maka akan dikirimkan kembali atau disampaikan kembali kepada tim. Jika sudah selesai, maka dapat dikeluarkan berupa dokumen teknikal. Baik itu dari spesifikasi, cost estimasi, kemudian juga gambar kerja, skematik diagram, juga check report. Dan technical documents ini juga dapat dikembalikan ke BIM Server Center dan diintegrasikan dengan physical model yang kita punya, sehingga informasinya menjadi lebih lengkap. Ini adalah tampilan CYPE Suite yang dimiliki oleh CYPE. Lengkap dari mulai Open BIM, struktur, MEP, kemudian solusi untuk simulasi atau CYPE term, terus kemudian estimasi, dokumentasi, dan juga infrastruktur. Dan ini adalah tampilan dari BIM Server.Center. Untuk solusi struktural, CYPE terkenal sejak dulu untuk solusi struktural yang luar biasa. Dimulai dari TrueBeam Steel, TrueBeam Uploader, TrueBeam Shear Walls, kemudian yang terkenal adalah CYPE CAD, terus kemudian TrueBeam Slab 3D, TrueBeam Rebar, dan terakhir adalah Embedded Walls. Sebenarnya masih banyak lagi solusi untuk struktural yang digunakan ataupun yang dihasilkan oleh CYPE. Untuk CYPE CAD, ini adalah aplikasi untuk melakukan analisis dan desain beton bertulang dan struktur baja. Tunduk pada gaya horizontal dan vertikal untuk proyek residensial, bangunan, dan pekerjaan sipil. Kemudian, untuk TrueBeam Site 3D, untuk penggunaan proyek struktur batang 3D menggunakan baja, aluminium, dan kayu, termasuk fondasi dan sistem penguat terhadap beban lateral, dan memungkinkan ikatan bekerja untuk tegangan sendiri, dan juga mendesain sambungan dan plat dasar untuk struktur logam. Sedangkan TrueBeam Steel, yaitu pembuatan model BIM yang tepat dan presisi, dan mencakup semua elemen yang diperlukan, mulai dari baut, plat, butt welds, terus kemudian jangkar atau angkur, yang menjelaskan tentang struktur. Hasil keluaran dari program ini menyediakan shop drawing dengan format DSTV, terintegrasi dengan BIM Server.Center. Kemudian, TrueBeam Rebar. Ini adalah aplikasi pemodelan BIM untuk perkuatan dan tulangan pada struktur beton bertulang, dan terintegrasi dalam alur kerja Open BIM melalui platform BIM Server.Center. Semua aplikasi struktural dari CYPE ini terintegrasi dengan alur kerja Open BIM melalui BIM Server dan Center untuk dapat saling berkomunikasi dan berinteraksi antar solusi struktur dari CYPE maupun dan solusi CYPE lainnya. Kemudian BIM Shear Walls, ini adalah aplikasi untuk mendesain shear walls atau dinding geser beton bertulang sesuai dengan SCI 31811, SCI 31814, NTC RSII 2017, dan Eurocode 2 dan Eurocode 8. Terintegrasi dalam alur kerja Open BIM melalui BIM Server.Center. Kemudian BIM Embedded Walls, ini adalah aplikasi untuk analisis dan desain serta pemeriksaan terhadap kesesuaian dengan kode standar embedded retaining walls. Analisis tidak linear dengan memperhatikan perilaku elastoplastis untuk tanah dan pendukungnya. CYPE juga mendukung analisis juga desain dan kalkulasi untuk desain parametrik. Melalui Open BIM, tentunya itu menjadi posibilitas yang terbuka. Sehingga semua bentuk-bentukan ini dapat dianalisis dan dapat dihitung melalui solusi struktural yang dimiliki oleh CYPE. Terima kasih. Demikian presentasi saya untuk sesi pertama hari ini. Jika Bapak Ibu memiliki pertanyaan atau ingin mengetahui lebih jauh tentang produk-produk CYPE, dapat menghubungi saya melalui email kemal@arkilantis.com atau juga menghubungi WhatsApp melalui nomor 0877 034 2087. Saya ulangi, melalui WhatsApp dengan nomor 08777 034 2087. Selanjutnya, pada sesi kedua akan diserahkan kepada Mr. Hernan. Mr. Hernan, it's your time now. Okay, good morning, Mr. Hernan. It's your time to presenting about the structural solution from CYPE.
Yes.
Okay. It's your time now, please.
Okay, so I will, could you share, please, the presentator panelist?
Okay.
Perfect, now.
Okay.
And now I will, okay. Perfect. I think I am sharing the correct screen. Good morning, everyone. Welcome to this demo of the different tool for CYPE for the task of analysis and design of building a structure. On my screen, I will show you our goal today and our model. Our model will have this form. This will be our building for today. We will develop all this model in this session. And to show the path, the different steps that I will try to show you, and the work that we need to do today, I will use this very simple presentation to detail the different steps. So our demo today will have this structure. The project, it's the central part, and our core will be three important points. The primary structure in reinforced concrete, the secondary structure in an special steel tetraedron, and the shear wall and the coupling beams. To develop every part of these 3 points, we will use 3 different programs. For the primary structure, we will use CYPE. In this case, we will develop a building on reinforced concrete with the different part of the structure, not only the superstructure, but the foundations on the same file, on the same project. And like accessories of that, we will use the secondary structure in steel elements on the top of the building. And to develop this structure, we will use Site3D. It's the correct tool to obtain this kind of results when the geometry of the structure is complex and not only composed of vertical elements and horizontal elements, but with different geometries than the building. For the third part of our demo, we will develop the shear walls and the coupling beams. On this case, we have a building with different elements with earthquake loads, and we have for these elements that need a special checks and a special program that is our StruBeam shear walls. Is a program that is on the platform BIM Server Center, and he have a relation and exchange information with CYPE on this platform, BIM Server Center, that it's called by Kamal Chu. So, in this case, this is the 3 important points of our presentation. So let's start. So to develop our primary structure, I will go to CYPE. I will develop a new project. In this case, I will change my version to the English version.
Okay, Mr. Hernan, I want to ask
Yes.
about the new version of 2021, version E. Have any development or maybe any more about the advance from the last version?
Yes, every the update of our programs in generally have some important points. We have users in a lot of different countries, so sometimes it's constant that some develops or some advanced have concentration on different countries. So for this version to 2021E, you can see the different points on our web. and you can see all the details of these different elements here. Okay, so we can see the version, and we can see the different elements that we change every version and the advance. Okay, this is the right way to obtain the different elements. So we will go to File, New. We can start with a new element. Would you like to override? Yes. And to start, we will use an empty project. We can accept. And here we can see the different codes. So in this case, we can use, for example, the American codes. We have different codes on our programs. You can see a drop-down menu with the different international codes and local codes. So for this case, I will use American code for every material of our project. And in this general data menu, you can choose the codes and the materials too. For every position of a structural element, floor slab, foundation, columns, walls, etc., you have a drop-down menu with the different materials that we have this available by default. But the user can also go to this little button, and the user can define here a library with the different material on different names, different characteristics from the default elements. So this possibility is available for the reinforced concrete and for the steel too. You can see the library for the roll and weld and cold form steel. On our program, it's important to know that we can develop the superstructure and the foundation too. So in this little button, we can define the soil resistance. We have a library with different soils with the most common values, and the user can come here and type the value of the soil resistance from the technical test. So after that, we have the loads. For the wind load, we have a menu with different codes. Every country with different codes have the possibility to define his own code. We have general method, for example, with a curve of pressions. And on this case, we have, for example, the American code that can be applied everywhere because we can define here the basic wind speed and, for example, take the value of the emplacement of our project. So we can apply the American code, the ASCE7, for our project everywhere. For the next step, it's with seismic load. We have also, on the same way, different codes from different countries, general method, and for the American code, we have the ASCE7, UBC, ABC. So the user can define a dynamic analysis method or a static analysis method. On this case, for example, we can with the different values and the different factors defined by the user, obtain an spectrum that will be applied to our project. I will leave here the default values and obtain this design spectrum that will be applied to our project. I can accept, I can choose, in this case, the criteria of reinforcement by ductility, in this case, category D, E, F, and accepting, I will close the main menu, and we can pass to the workspace. So for the workspace, we can see here that this sheet at the left below will show us the different steps to develop a project. So we have the column definition, the BIM definition, results, contour maps, and health and safety. In general, we will use the 4 first sheets: column definition, BIM definition, results, and contour maps. So we come back to the column definition to go to the introduction, floor groups, new floors, and we can start with a single one. So it's important to know that we will use just a tip in order to define only a floor, and after that to repeat and copy this single floor 9 times. Like that, we will obtain our building. So here the user can define the light load and the dead load. So we can type the values by the keyboard, we can accept, and we can start in this workspace to define the columns. So here the user have different ways to define the position of the column. Using this virtual axis, the user can also define grid lines with horizontal and vertical lines to position the different columns. And we can also use the DXF or DWG file. For our case, I will use this way. So we can go to DXF and DWG file. I will select the file with the information that I need, and we can go to plus to select the information. This is the menu where the user can view the information that he will use for the project. So from this file, I will create 2 different views. In this case, I will copy that. You can see that we have here the geometry of the building, and we have also, we can unselect all, and we have the axis. Okay, so for this case, I will name axis this view, and for this the plan sketch. I can accept this, and now I can manage the different views of this information. I can see only the axis, for example, okay, or I can superpose the geometry of the building and isolate only the building. This is an interesting way to see all the information about the architecture of our building. This is a way to develop our project, but there are some different ways too. So on this case, I will define the columns. So for define a column, I go to the introduction, columns, and here we have the menu. We have the reference, we have different characteristics of a column. On this case, I will use the geometry of a square and reinforced concrete, but you can see that we have different materials and different types. So, for example, I will work on the different options. I can see for the steel, the rolled steel sections, the cold form steel sections, and the different types. We have a library with different profiles, and the user can import the default libraries and define his own library too. So the user have a lot of different options in order to adapt the program to his own project. So we have also timber, we have composite sections composed by the reinforced concrete and steel, or for example, contour on steel and inside reinforced concrete. So different combinations. And the most generic is generic material and generic section 2. So for our project, I will use the classic one, the 40 by 40 centimeters. We can accept, and I will use, on this case, the template object snaps to select the position of our columns. And I will start here. It's only click left. We need to approach to the position of the snap, the DXF or DWG snap, or I can use the virtual axis or the lines defined by user. It's the same result, different ways to work. In this case, I need to delete this element, okay, and I need to edit this column that have a different position that I need. Okay, so I have the columns. I can pass to the next sheet, BIM definition, and I can show the advance of our project with a 3D view. Okay, so we have the columns. So next step, I can go to the line sketch to define the different walls. Here in BIM definition, I will define the elements that define the contour of slabs. So how can I define a contour? With walls and with beams. So on this case, I will use both. So I can go to define walls, the menu walls, and define wall. We have this menu. We have different options here: reinforced concrete wall, plain stress walls, reinforced concrete block wall, and masonry wall too. For our case, I will use reinforced concrete walls. This is the menu for the definition of the reinforced concrete wall. So I have here the option to change the dimension of the left and right from this axis, the central axis of the wall. We can add pressure to this wall. For example, in the case of an underground wall, we can add these pressure diagrams, defining the kind of soil. We can define the type of soil, and the program will calculate the pressure for the wall. And the user can also define a curve of pressures with different points. And for example, for different elevations and different values of pressure, and the user can use this to define the pressure for the wall. On this case, we will not have a pressure on walls. It's only an example. It's to show the different options that the user have. For our example, I will use a fixity, and the foundation, I will define the foundation after to define the wall, not at the same time. So I can accept this, and I will define the position of the walls. As you can see, it's not exactly the same position, but you will see that we have different tools on the program to adjust the position of the wall, and after that modify the length of the wall and adapt the dimensions to the exactly needs for the project. So I need to approach to the CAD file, and talking about the tool adjust, I will go to this little button, or I can obtain this same tool here. Okay, so on this drop down menu, and use the snap nearest in order to position the wall with the needs of the architecture plan. Okay, this is the result until this moment. Okay, so now I will complete the wall, for example, for the cores, for the leaf. and adjusting. I will finish. We can also erase these elements that we don't need. And a 3D view will show us the advance of our project. Okay, so right until this moment. So now we need to complete the different contours, the perimeters, and we need to complete that with the beams. So to introduce the beams, we will go to the menu beams. We can define beam. We have this menu where we can see the families. So flat beams, drop beams, foundation beams, steel beams, timber beams, etc. And for every family, we have different types. In this case, we will use the rectangular drop beams, but as you can see, we have the other choices too. We have, for example, the T-beams, inverted or inverse T-beams, or for example, the inverted rectangular beam. So we use for our project the rectangular one, and in this case we will use the width of 30 centimeters by a depth of 45 centimeters. We can accept, and we will use a very interesting tool on our program that's called Snap. From this DWG file, the architect, or saying the user of CYPE have already defined a polyline following the contour of the building, and the program with this tool, Snap, can follow this polyline with the beam. So I approach to this polyline with the definition of the beam, and clicking left, you will see that the program follow this polyline defining and these elements. So I will go, on this case, to the next level. That is very, very important. You know that I am on the foundations, but I can go to the next step. It's next floor, next level, it's the floor. And here I will sketch, and I will repeat the same process. Now it's the correct level. So we have the perimeter. We need only to complete the different elements that make the function of support of the slabs. So to complete the position of the different beams, we can use this tool that is extend beam, and we can extend some of the beams to complete the geometry of our building. If we need to define other beams, we can go once again to define beam, change to the tool simple, and we can go approach to the column, and you can see a red point. This red point, this red circle, mean that an element it's detected to define the position of the beam. We can position the initial point of a beam on a column, on a wall, or, for example, on this case, on other beam. Okay, so I will go to this column. We have different tools. For example, in this case, I will use the orthogonal to complete the support of the beams. We have a rack here, and you can see that the beams have limited the section of the wall. So now we can delete the elements of the wall that we don't need. Okay, and now we complete the other beam. A 3D view will show us the advance until this moment. Okay, we can see the different columns, the walls, and the slab or the virtual slab that the program defines when a contour is closed. So now we can go to the slab panel manager. We can define a panel, and we will use this tool later to define the walls, the slabs. Sorry. So at the beginning of our presentation, we talk about the shear walls and the coupling beams. So until this moment, we have here the different walls, but we don't have elements with the necessary dimensions to be a coupling beam. So we will define on this position the necessary beams to be a coupling beams. So for this, we will go to beams, define beam, and we will tape the depth 100 centimeters. We can accept, and we can approach to the end of the wall and going to the next wall. We define these beams that will manage like a coupling beams. Okay, so how we can show to the program or define to the program that this element have different characteristics or different features from the others. So on this case, we have on the menu walls the tool assigned to act as a shear wall. on CYPE, the model is managed by finite elements, and the reinforced concrete is obtained point by point of these finite elements. But if we need to integrate it, the forces, we can also check the different values that is needed to do with the code. On this case, for example, we can apply, or we need to apply an earthquake load, and these elements will be an different features, or will have special characteristics. So to show that to the program, we will go to walls and assign to act as a shear wall. In this case, we can define the name, define a number, and we can assign to select the different elements that will act like a shear wall. This information and this geometry will be exported to the BIM Server Center, and after that imported on the program shear walls and StruBeam shear walls, and will manage like that. So next element, next one, the core of the leaves, and the core of the leaf on the right. So these are the elements that we have selected like special elements. Okay. And you can see the coupling beams that will be selected too. How we can select these elements here in define coupling beams and assign for these beams this feature or this characteristic. Okay, so after to design and select all these elements, we will complete our floor with the slabs. Here the user have different options for the joist floor slab, composite slabs, waffle slabs. The user can also use the mat foundations with the soil resistance and subgrade modulus. For our example, we will use the flat slabs. It's the simplest. We need only define the depth. Accepting this menu, we will go to the workspace to click on the close perimeter, and clicking on this beam, I will take the direction of the axis to define the direction of the reinforced bars. And we can copy panel, and selecting by window, copy these elements to all the others. Okay, so I think we have the model for this floor completed. So now we will come back to the column definition, and we will go to the floor, new floors. We can select this level. We will define single floors, and we can define an height of 3 meters with a live load of 0.20 tons over a square meter and dead load 0.2 tons over a square meter. We can repeat these values 9 times, and accepting, we can pass to the next sheet BIM definition, and we will show the result of the action on a 3D view. So, and remember this is our primary structure. We need only complete, on this case, the foundation. The foundation will not be our star today, but I will only show how we can define the foundation. So on this case, I will switch off the information of the plans, of the drawings here, and we can go to the menu foundation elements, and we can define a new element to see the different options. So we have footings, we have also pile caps, and we can define with this little footing, it's in this case the arrow of the mouse, we can clicking left position the footing for the single columns. We can also define for these walls a footing, and for this element that will be combined, I can right click, and we can select multiple column elements. We can accept, and this time I will select by window 2 columns. Clicking right, I will finish the selection, and the mouse, the arrow of the mouse, come back once again a footing, and I can click left to define the foundation. Repeat the process here, and a footing is defined for combining the two reaction of the columns. For the walls, same way. We can also remember, we can define the beams, the strap and tie beams. This is more or less the process. It's a very friendly process. We have different tools in order to define all these in the very fast way and a simple way too. Three D view. And we have our primary structure defined. So we can see on the on the slides that we need to define a secondary structure with CYPE 3D. And why CYPE 3D and not CYPE-CAD? CYPE-CAD is the program that I am managing here. It's a program that focus or concentrate his forces and his strong point on buildings. Buildings are composed generally by vertical elements like columns and walls, and horizontal elements. In this case, for example, walls, beams, etc. So when the geometry is more complex, or there are different bars in the space, we need other tool. But this other tool that is CYPE 3D can work integrated the strong point of both programs. So how can use CYPE 3D integrating this structure or this complex geometry on a primary structure of CYPE-CAD? We can see here the menu 3D structures, and we can go on the level we need to define an different geometry. Go to this menu, we can define new structure, and we will define some connections. So we will define other structure will be connected with the primary one. So I will define, in this case, these 4 connections. I will click right, validate these connections, and we will obtain, on this case, the workspace of CYPE 3D. For this case, I will have different tools from CYPE-CAD that will permit me to define geometries more complex and different type of geometry that on CYPE-CAD I cannot be able to do. So for this example, I will show how to define this kind of structure. Tetrahedron, very spatial, and an important number of bars. This case sometimes appears on our buildings, where we have a primary structure on the reinforced concrete, and will have different secondary elements in order to complete the functionality of the building. So I will complete our primary structure with the secondary one, and we can start with the definition of the bar. We have here different type of material selection and section selections. For our case, I will use the cold form steel section. In this case, a circular one, and I will use from the commercial series, the 512.1. We can accept, and connecting this initial point to a second node, I will define 4 columns on steel. And after that, I will define the spatial structure as we see on the image. For this structure, I will use a circular section of 3 values, and I will use these elements to the generation of the structure. So define these main elements. I will use a tool of the program that is called generation, and I will generate a tetrahedron mesh. I need to define now the beginning of the generation, the ax 1 for the generation, the ax 2 for the generation, and we have here a draw remarking the different step and the different elements that will be compose this generation. So for this ax 1, I need to define the segment divisions. Remember that we have here 10 meters. Maybe I pass very fast there, but you can believe me. We have 10 meters. And for the second one, I have 5 meters. I will divide them so this bar on 5 elements. And the distance between planes will be 1 meter. We can accept, and we have the structure. Now I need to, these are elements that don't have defined yet the section. So I need to go to describe, and I will select all the elements in order to define his section characteristics. We can go to Tools, 3D View, complete the structure, and we have the structure. If I need to extend this structure to both sides on both directions, I will use different tools from the program to do that. Okay, so the user can use these different tools not on the same way, but on different way to define geometries of his projects. So I go to this little menu to obtain different combination of direction of axis, and I can see in a 3D view from a side. Okay, so to extend this spatial structure to both sides, I will go to the menu Tools. I will copy elements. I will select nodes and bars, and selecting by window, I will copy these elements for both sides. I will have, maybe I have much more information. So, and now I will repeat the action for the other side. As you can see, I extend the structure to this side. So, and now I will repeat the action to extend for the other direction. Selecting the elements, selecting this one too, and now to the side. Repeat, copy elements, and now a 3D view of the complete structure. So we have our structure. On CYPE 3D, the self-weight of the elements is take into account automatically, same way that on CYPE. But if we can, if we need to, for example, add some loads, we can go, for example, to the menu load, introduce loads on bars, or introduce loads, for example, on nodes. We can select, for example, all the nodes of the top surface of the top plane, and we can, for example, define a lead load of, for example, 100 kilograms in every point. We can go to the menu load to change the scale. I know that it's a very little load, so I need to change the scale in order to see on with more detail. And as you can see, I add the different loads to every point of the element. We have the self weight too, as you can see. The self weight of the bar is taken into account automatically by the software. So now we can come back to the primary structure on the workspace of CYPE, and obtaining a 3D view, we can see the primary structure and the secondary too. Okay. So if the model is complete, we can close, we can save the model, and we need to complete the process, go to the analyze and launch the analyze. At the same time that we launch the analyze, we will obtain the discretization of the structure, and we will obtain the forces, stress, and the sign of every section. So in order to save time for this demo, I have the complete model with the results. So I will open this complete model with the results, to show you how we can control the results and edit the different sections, and the process to export all this information to our platform, StruBIM, to the platform BIM Server Center, and import all this information, the necessary information, to the StruBIM Shear world. So here we have the complete model with the results. generally, the user have different tools to control the results. These tools will be available on the sheet results and on the sheet contour maps. Okay. Generally, the first step that we make like user at the end of the analysis and the design, we go to, and I said generally because people have different habits for that, but in generally, I will go to the deformed shape. For me, it's the better way to obtain or to see the behavior of the building for the different load cases. So we have the discretization. We can view the structure to superpose, overpose to the model. We have, for example, here the possibility to see different information for the displacement on the screen. Okay, so we can, for example, go to a different load case. We can exaggerate just a little the factor, and we can see, for example, the displacement for the secondary structure, for example, and for the secondary one. These different load cases will show the general behavior of the building. We can also obtain the view structure, and we can see different values. So the next step, generally, I will go to the contour maps. For the contour maps, we have different tools, and we will control on the result of the floor. When on the first deformed shape and the first control that we can make is the general behavior. And in the case of contour map, I will control the behavior of every slab, okay, and floor by floor. So generally, the tools here are designed to control the result and the behavior of the slab. So we have, for example, here the ISO lines, the ISO values. We can see, for example, the displacement. We can control here the deflections. We have the tool deflection. We can see on the general view of this floor the points that we have the deformations, the most important, and we can control the values going to this tool, deflection between 2 points, and we can, defining these 2 points, obtain the result for the deflection and the absolute value and the relative value for the length. Okay, so in this case, it's the user that can control if this deflection is over or under the limits that in general code makes some advice. So if the deformation is over the limits, the user need to modify the model in order to obtain less deformation than the initial one. So to control the, on this case, the forces and some other values, we can, for example, go to this little tool that is very, very interesting for me because I have so much information with this little tool that we can select a strip width of 1 meter, for example, go to one of the forces that is interesting for us, for example, the moment, and we can select, for example, the load case or a combination, for example, and selecting a direction for the slab, I will obtain all the forces integrating in this strip of 1 meter and obtain the maximal and minimal values. With these values, I can go to other tool to verify or to obtain a control over the reinforcement that the program obtain. So like I can show you that the program design the section, but if I want to control or to verify this section, I can obtain the forces and by hand or for another with other tool, I can check this section of the design. That is for me very, very interesting. So other tools that we can use in order to control the result. Remember that we have the edition for every element that we define on our project. For example, we can follow the weight or the path of the different loads. We have the behavior of the entire building. We have after that the contour map, and now we can go to the beams. So we have here for every beam and every frame the results. We have so group by group the different frames with a plane view of this frame. Okay, we can see on this case we have the frame 2. We have the force diagrams. We can see the persistent or transient forces or the seismic ones. We can see these forces or surpose, overpose or on the frame or below the frame. We can obtain the different values. Okay, following the frame, we obtain the values of the forces. And as you can see, we have also the reinforcement. So for the reinforcement, the user can also edit the proposed reinforcement that the program made. In this case, this section is automatically proposed by the software with the analysis and the result of the different stress and the code also. And the user can came here and change, for example, the section. So after edit the section, the user can go to the this little button, update errors information, and as you can see, one red point, one red circle showing show as a warning. Remark that the section that we edit have an warning or an error. If I need to, or I want to obtain a detail of the section, of the error of the section, I can go to the ULS report, select the section, and we can obtain a detail of all the checks that the program apply to this frame. All these report can be obtained on different formats. Okay, and it's very, very detailed. I love this report. It's the best way to communicate the result of our project. Nothing is hid on this report. We can every time go to this report and see what the program apply for every section of the frame. That is incredible. So we can apply some different characteristics for this frame or for this beam. We can edit the longitudinal reinforcement. We can see below this part or this part of menu. For example, I will select only this part of the frame. I will show that this element, this part of the graphics, show us that in red we have the necessary section for the beam, and the green one is the section applied for the section, the reinforced section. So in this case, we can see that the necessary section is bigger than the real one. So it's for this reason that we have an error. We can come back to the original values, and now we can see the green line over the red one. So in this case, we don't have a warning. So we can update error informations, and we can see that all the checks pass the values or the necessary limits from the code. So other interesting tools on this edition. For example, the openings, we can apply openings to this beam. We can apply, for example, to pass some pipe installations or something. We can position this element and to apply this reinforcement, and after that the program will apply the checks to know if the new section, the section, the detailed section, pass all the checks or not. Okay, that that is very, very interesting. So now we can go to the columns. For the columns, we have also a similar menu, especially designed for the columns, obviously. Sorry. So we have the different floors, the section, we have the longitudinal reinforcement or on the corners, on the X face, Y face, and here we have the drawing or the different position of the reinforcement for the bars and the stirrups and transversal reinforcement. We can edit every value of all these. We can propose a different section. We can, in a drop-down menu, select all different section for the reinforcement bar. We can modify also not only the diameter of the bar, but also the number of the bars. I can apply, for example, 4 and 4. For example, here you can see. And now, for example, I can modify and apply other kind of stirrup. Okay, so all this is possible made to the software. And after this edition, I can pass the code checks to know if my edition pass all the checks or not. You can see all the checks pass. If I need to have more information about my the different combinations, the different load cases, we can also obtain more detailed information here with the surface. We can also obtain all the combinations. We have page and page of information to know every detailed section of the column. And remember that we can also see the different forces. Okay. And we can see a 3D view. All this information will be available on different formats. We have programs to manage all these, but if we can go just right now with an 3D view, for example, and DXF or DWG format, we can export all this now with this format and obtain information that can be useful for the user. For every column, we have, for example, the possibility to obtain, for example, the code checks. Remember that the program make and pass all the checks, not only for the forces, but for the code too. In this case, this important check for the strong column and weak beams, the check for the node is made automatically by the software, and with the real reinforcement, not with the necessary. That is very important too, because it's most exactly made the different checks with the real section of the reinforcement. And all this is made automatically made by the software. We have the export to the different formats. And we can see a page preview with we will show you a preview of the report. Every check is detailed by the software, and we can control all the. So now we can, yes, remember that we have different reports. The job data report, for example, the most complete, and I think the most useful. This is necessary in general to present that, because we have here the geometry characteristics of our project, the combination, the codes applied, the different forces, the geometry characteristics, floors, columns, materials, etc. This is the first report that we need to obtain from the software. And after that, we have different reports and very useful reports. For example, we can go to the justification of the seismic action. Absolutely necessary when we have low earthquake actions applied to our project. We have all the characteristics of the forces applied to our project, the design spectrum according, and the different values for the natural characteristics of our building, the center of mass and stiffness, on coordinates and on drawings too. And we have also the justification of the base shear condition verification is made automatically by the software. And we have here the different earthquake and the forces floor by floor. Other very interesting report is, for example, because economy is always important on a project, so we have to control or to have an idea of the economic characteristic of our project. The report for this. So we have level by level, floor by floor, the formwork, the volume of concrete, the weight of bars for the steel bars, and we have all these details for all the floors and a job total, having the volume of the concrete, the weight of reinforced bars for our structure and the surface and the formwork necessary to have this structure like a reality. So yeah, it's an interesting way to obtain an economic idea of our structure at the end of the analysis. All this is very, very interesting. On different programs have to obtain that on other programs, we need to apply different process or to go to different tools. On CYPE, we can, at the end of the analysis and design, obtain all this. This is a save of time and very interesting to take decisions. So, in order to obtain some values of the structure, I will go to the last level of our primary building. I can edit the structure for the steel tetrahedron 1. Remember that we have also the forces, displacement, etc. This is a secondary one. Remember that the objective of this demo is to show just a little the workflow, not go on the very little details or the manage. I remember that we have others demos for this, but remember that we can have here the analysis, the forces, the form shape too.
I'm sorry, Hernan.
Yes.
Sorry. Yes. For a while, maybe we will conduct the question and answer during your
Yes.
presentation.
Yes.
Your presentation will continue. Dan Bapak Ibu dan teman-teman, jika ada pertanyaan, bisa menuliskannya di kolom chat. Nanti dari host akan meneruskannya ke kita langsung, agar nanti dipilih untuk nanti kemudian dijawab oleh Hernan. Silakan Bapak Ibu untuk menuliskannya di kolom chat. Terima kasih. Please continue, Hernan.
Okay. So now we can see, for example, the force diagram, envelopes. We can obtain also the different checks for every element, like on more or less the same way that we obtain, or the same format that we obtain for the other elements. So we have here different ways to obtain the reports. And remember that we have on this primary structure some elements that need an analysis and special checks, because we have shear walls with possible boundary elements and the coupling beams is this. So how we can obtain the checks, the special checks that we need to control or pass for these special elements? To do that, we can go to this menu, is BIM Server Center. We can export all this information to the BIM Server Center platform. I have here. This is our platform of exchange information. We have an store with different applications. Some of these applications are free, others want by pay. And the user of this platform can exchange information of this of the different project here. For example, I have this project that I create. I can see here a 3D view with the different information that every specialist pass me. For example, here we have the structure and the stream shear wall. Okay. So with this information exported by CYPE, I will go to the program stream shear wall. If you can or if you want to evaluate this program, you can obtain this program in evaluated version on our platform. You can go to store and search on shear walls, and you can obtain and upload the program, and you can combine the CYPE and the stream shear walls on the different tasks. So on this case, I will obtain on the stream shear walls this model. We have here two. This is the workspace. I will describe the workspace for the shear walls, coupling beams. We have two different sheets to manage the two different type of elements. And for every shear walls that I already defined on CYPE, we have the different values and the different checks. Remember that we had two core and other 4 elements, isolated elements, and we had also some coupling beams. The coupling beams have to a sheet to pass the check and design the section. In this case, we can apply on this the different codes. For our project, I applied the ACI 318. And it's very, very interesting to know that we have here different checks for the boundary elements if it's necessary, according with the forces and with the code 2. We have the sections, and we can design all the walls, design a span, and we can see a 3D view of all the different sections.
Okay, Hernan, we have a
Yes.
question about some question passed to me
Yes.
from the host. First of all, how about the SI unit on your presentation? Can you do it?
The units on CYPE,
Yeah,
we
on the CYPE SI.
we can change the units here on this bottom, and we can pass to the different units of
And about the workflow, can you open several window views such as the working 2D and 3D at the same time with the CYPE?
With the CYPE 3D, are you talking about work
Yeah,
on
on
this
several window.
on the
Yeah.
model? From the workflow, and on this case, we work on the main structure on CyPE or in the workflow on the workspace of CyPE 3D, not at the same time.
Oh, not at the same time. Okay. Okay. And can you import IFC files and then continue with CYPE for the structural analysis and add BIM openings, for example?
Sorry, could you repeat, please?
Can you import IFC files and then continue with CYPE for the structural analysis and add BIM openings, for example?
Yes, I have different ways to define the structure and obtain information from the architect or from the project. So on this case, I choose a way, but we can also define the geometry with an AFC or with a BIM file. So in the case of choose the IFC, we only have the opportunity to define the geometry only one time. But when we use the platform of BIM, we can exchange information and on both ways. So export and import. So yeah, if the project can suffer a change on the process of the project himself, the best way to start with the structure is to start with the BIM building philosophy. So with the platform, the architect can export the information from a BIM modeler, like for example, our program, the BIM architect, and the software CyPE can import this information, and at the same time that the software of architectural model may change, we will have warnings on CyPE calling about this change, and we can advance on in a parallel way with the structure and the architectural model. So I think it's nowadays is the best way to work. So overall, with the project is complex or a big project, it's I think this the best philosophy and the best workflow. So we have other
Okay,
question.
I will check. Okay, we'll check. How about the license? All the people always ask about the license of CyPE.
Okay.
The licensing of CyPE. Are they subscription or this is perpetual?
In general, our licenses are perpetual. We don't have payment by year per year. It's we launch a version every year, and we can work with the ancient version, no problem. We will not lose your license next year if you don't want to update or pay for the next one, because maybe there nothing interesting for you, and you are very happy with your ancient version. You can stay there, and the version will work without problems.
Okay.
Maybe it's interesting to at the end of our demo, maybe interesting, Vicente can add some information about that. I think it's interesting too.
I was also answering in the chat to
Okay.
the person that was
Okay.
talking about.
Thank you, Vicente.
Okay.
Some other questions?
No.
Okay.
It seems like no other question for today. Thank you for the nice presentation, Hernan.
Thank you. To you. Remember that we have not only the stream rebar, but also we have the stream shear walls. We have a lot of different tools in order to obtain all the information of the project, to enrich the result of the projects. We don't focus only on the analysis, but on the design. We can obtain the drawings, that is very important. We have the possibility to obtain the very complete drawings in a very simple way and very easy way in different formats. I think is the most important characteristic of the program, of our tools. I will show only a preview of all the drawings that we can obtain at the end of the process, and we have also a very strong point with the technical support. For example, here we can see all the drawings that we can obtain only with 2 or 3 clicks, and this is a very interesting way to save time and enrich the project. With only 2 clicks or 3 clicks, you will have all this information immediately after the launch, the analysis, and the design. And this is, I think, the most important and the most strong point of our tools. We don't focus only on the analysis, but on the very important task of obtain all these drawings, all the layouts, and all the information that is necessary and essential to finish the project. And it's for this that an engineer is paid for. And so we don't only focus on the analysis, but in obtain the project complete.
Okay,
all these are the frames and the beam. Okay, so
okay.
thank you.
Okay, thank you, Hernan, for the presentation. It's very nice, and it's very complicated I mean, it's a very comprehensive from the end to end about the structural designs and structural solution from this CYPE. Dan terima kasih kepada presenter webinar hari ini yang sangat luar biasa. Kita tadi sudah lihat bahwa solusi struktur dari CYPE itu sangat luar biasa, bahkan dapat memenuhi kebutuhan dari setiap kebutuhan kita untuk menggunakan solusi ini. Kami ucapkan terima kasih kepada presenter webinar hari ini yang sangat luar biasa. Sebelum acara ini ditutup, kami ucapkan juga terima kasih kepada peserta yang telah senantiasa menyaksikan webinar ini sampai akhir acara. Kami mohon maaf atas kekurangan selama memandu acara webinar ini. Dan jangan lupa, masih ada rangkaian webinar lagi tanggal 16 Maret 2021 dengan waktu yang sama dengan tema Plumbing and Fire Protection Installations, Design, Adopting, and Open BIM Workflow. Terima kasih banyak kepada Mr. Hernan atas presentasinya. Thank you very much, Mr. Hernan. See you in next webinar.
Thank you.
Bagi teman-teman yang ingin menonton ulang acara ini, materi presentasi dan rekaman akan kami kirimkan melalui email. Saya Kemal, Arkilantis, dan CYPE Indonesia mohon undur diri, kiranya acara hari ini dapat bermanfaat bagi yang menyaksikan. Sampai bertemu pada webinar kami berikutnya. Terima kasih dan selamat sore. Thank you.
Bye and thank you.
Wait for the minutes, Hernan. We will take a picture. Okay. Okay. Okay, Vincent, there's any others? Okay.
Okay, so we finished, right? Thank you very much.
Thank you very much.
Thank you. Bye.
Bye, Hernan.
Bye.
Bye.